I'm Ivan Lopez, Ilomar on Twitter. I work at Object Computing. OCI, it's the company behind both frameworks, Grails and Micronaut. But today I'm not going to talk about Micronaut. If you are interested, we can talk afterwards. I'm from Madrid, from Spain, and I'm also the coordinator of the Groovy user group. And I used to organize Grids. For the last 7 years, Grids was a conference focused on the Groovy ecosystem. For this year, there is a new organizing team, and they opened the scope. It's now a JVM conference. It's actually next week in Madrid, and there will be talks about Java, Kotlin, Spring, Micronaut, a lot of things. So if you want to come to Madrid, you still have time to get a ticket. And I'm also a regular speaker at different conferences. So I want to start with a video of what happens, or of what could happen. Maybe some of you already know this video, when you have a voice interface. So let's see how it goes.
What's the buttons?
Oh no, they installed voice recognition technology in this lift. They heard about us.
Voice recognition technology in a lift in Scotland. You ever tried voice recognition technology?
No.
They don't do Scottish accents.
11.
Could you please repeat that?
11.
11.
You need to try an American accent. 11. 11.
That sounds Irish. You're American.
No, doesn't it?
Where in America is that? Dublin.
I'm sorry. Could you please repeat that?
Try an English accent, right? 11. 11.
You for the same part of England as Dick Van Dyke.
Please speak slowly and clearly.
If you don't understand the lingo, away back came to your own country.
Ooh, is that talk now, is it?
Oh, don't start, Mr. Bleeding Heart. How can you be racist to a lift?
Please speak slowly and clearly.
11. 11.
You're just saying it the same way.
You're going to keep saying it until I understand Scottish, alright? 11. 11.
I'll just say it's anywhere, you cow. Just open the doors.
This is a voice-activated elevator. Please state which floor you would like to go to in a clear and calm manner.
Calm. Calm. Where's that coming from? Why is it telling people to be calm?
Because they knew they'd be selling this to Scottish people who'd be going after nuts at it.
You have not selected a floor.
Aye, we have! 11!
If you would like to get out of the elevator without selecting a floor, simply say, "Open the doors, please."
Please? Please? Suck my wally.
Maybe we should just say please.
I'm not begging that for nothing.
Open the doors, please.
Please? Pathetic.
Please remain calm.
What do you want up to that? Get him up there! Hey, just wait for it to speak!
You have not selected a floor.
Ah, girls, you cow!
Scotland, you bastard!
Scotland!
Scotland!
Scotland! Freedom! Freedom!
So yeah, something like that can happen when you use a voice interface. So you need to think about something like that. Before going into any details, a small disclaimer. I don't work at Amazon. I told you that I work at OCI. I'm not relating to them. They are not paying me for doing this talk. I'm just a developer that tried these things, and I want to share my experience. Everything started 2 years ago in March 2017. One colleague from OCI came to Madrid to Grids to give a talk about Alexa and Groovy. And after the talk, he gave me this small speaker, this Echo Dot. This is the version 2. Now you can buy the third one. And then that same year, I went to the US for a conference, and I said to him that if he can buy me one. So I've been using these devices for 2 years now in English. And then last July, they opened the new. They started to support the Spanish language. So I created a skill in Spanish in June or July, and they gave me the big one, the Echo, the full, for free because I created a skill. And then a couple of months later, I I created another skill, and they gave me 2 of them. So now I have 5 devices at home, and I only pay $40 for one of them. So it's amazing, right? So they do that because when they introduce a new language, they want to have a lot of skills. So they create this kind of promotion for developers to create skills, and they gave a lot of devices for free. So if sometime in the future they start selling these devices here, try to create the skills at the very beginning, because you can get a lot of them for free. So I think that one of the first things we should talk is about security, because is there any kind of security? We are using just our voice. There is no username, there is no password, nothing like that. It's just the voice. And probably it can happen something like this. Hello, welcome to our house. Thanks for inviting us. Alexa, order 2 tons of cream corn. Alexa, confirm purchase, right? This can happen. And this is a nice way to check if there is some always-on device listening when you go to someone else's place. And this is from XKCD, so it's not real life, right? But this is actually true. A little girl, said this to her Alexa device. Alexa, can you play Dollhouse with me and get me a dollhouse in the US? And what do you think that happened? What happened was that 2 days later, an Amazon package arrived at home with that very big box of cookies, 2 kilograms, and that dollhouse, you can see the size of the box. It was a dollhouse that cost $170. So it was a surprise for everyone. On the one hand, the girl was freaked out because she just talked with her Alexa device and got a dollhouse, which was exactly what she wanted. And on the other hand, the parents also freaked out because they didn't explain why that happened, right? So this was a funny story, and it was shown on TV. And they interviewed the girl, they interviewed the parents, and the news reporter said live on TV something like that. I love the little girl saying, Alexa, order me a dollhouse, right? And you can see the verb. Order, pretty much the same, right? So what happened was that live on TV, all the people that was watching that news, all the Alexa devices got activated and start ordering a lot of dollhouses into Amazon, yeah? So I think it was a lot of them. Probably Amazon detected that or the people and canceled the orders. But the thing is that a news reporter activated the devices at home, right? Because there is no security at all. And of course, we have South Park. They trolled everyone on the first episode of season 21st. I'm not going to play any video here because it's way too offensive. It's going against any code of conduct. But you can find it if you want. It's pretty simple to find it. And what Carman did was he added a lot of disgusting articles to the people shopping list. He also set alarms at 7 a.m. in the morning on a Saturday. And finally, what he did was he started saying in different phrases. So he said something like, hey Siri, can you repeat? Okay, Google, blah, blah, blah. Alexa, can you repeat that? So all the devices were talking one to each other after the video. So it was really funny. And you can find online videos of people that were watching the show and got their devices activated and started to repeat a lot of disgusting phrases. So this actually can happen. So you need to think always about security. But even with that, so with that problem, what can you can do with Alexa? So you can do a lot of things. So for example, you can play music. You can say, play some rock from the 80s, play some specific song, some from YouTube, whatever you want. You can get weather information. So you can say, Alexa, how is the weather today in Bucharest?
In Bucharest, Romania, it's 12 degrees Celsius with mostly sunny skies. Today, you can look for partly sunny weather with a high of 17 degrees and a low of 4 degrees.
Something like that. You can get the news, some calculations. So you can say, Alexa, how much is 10 factorial?
10 factorial is 3.6288 million.
But you can also ask for a very big number. You know that factorial grows really, really fast. So you can say, Alexa, how much is 100 factorial?
100 factorial factorial is 9.333 times 10 to the 157th power.
They actually fixed this because a few months ago, you know that these numbers, it's really, really big. So the device start saying numbers one after the other for more than 3 minutes. But now they fix it or improve it, the user experience. You can set alarms, or set me an alarm for tomorrow at 8 in the morning, or a timer. I want a timer for in 25 minutes, something like that. If you have your calendar connected, you can ask for your calendar. So what's on my calendar today? Add something to my calendar tomorrow at 9 in the night, whatever you want. You can add something to your task list, to your shopping lists. You get the traffic, and a lot of more things. You can do a lot of things with this. And why with the voice? Because remember, we always need to keep security in mind, but why we can use, or why is probably better or it's not better to use the voice. We all have phones in our pockets, and we are very used to use the phone for anything but to talk with people. But we are used to use the phone with our fingers, with a touch screen. So if we think about using only our voice to control something, does it really make sense? So let's see a couple of examples. Imagine that we want to add something to our to-do list with our phone, right? So we need to find the phone, we need to unlock it, find the right application, find the list that in which we want to add the item, type the task or the to-do we want to add, click done, exit the application, and put away the phone. Or we can also say something like, Alexa, add book flight to my to-do list.
I added book flight to your to-do list.
And that's all. You can do it with your voice. You can do it while you are doing anything. You don't need to worry about to find your phone or do whatever you want. So maybe it's an improvement. I have another example. Imagine that we want to turn off a light. So again, we need to find the phone, unlock it, find the right application, select the room or the bulb that we want to turn off, tap on the button, exit the application, or put away the phone. Or we can also say, Alexa, turn off the lamp. Yeah, maybe it's... So what should happen, yes, it should say yes, okay. But because I have a Wi-Fi power plug at home in Madrid, and maybe the Wi-Fi is not working or whatever, but you can do that. You can turn off a light or turn it off. Alexa, turn off the lamp.
Okay.
Yeah, so now I turn off a lamp in my house in Madrid, 2,000 kilometers away from here, without using only but my voice, right? So it's not a big improvement. I mean, we can also do or use the manual analog option, which is get up off the couch, go to the switch, click it with our hands, and go back to the couch again. So it's not that's a big deal, but we can do something like this. So these are the devices. There are different ones. Ones with a screen, another bigger and smaller. But what is actually Alexa? So the Alexa is not inside the devices. It's just the cloud-based voice service that powers these devices, and everything is running on the cloud. These devices actually are not. They don't have any intelligence. They are just speakers. Some are better, some are not that better, and with some omnidirectional microphones. This has 4. The big Echo has 7. And the devices just connect to the internet, to the Amazon cloud service, sends our voice, and gets some text or some voice back and play it. So there is no intelligence in these devices. And how does it work? So we have the user, we have the device, and we have the cloud service. And when the user sends something, the voice is sent to the Alexa voice service, and if it's something that is some kind of built-in inside Alexa, so something like I said, calculation, getting the weather information, something like that, Amazon will return back the voice and the information to the speaker. But if we are using a skill or we want to do something with a third party, the cloud service will send a JSON to an external dependency, an external server, get some JSON back, convert it to voice, and finally play it to the user. And also, we have this option to create a card These cards are some kind of graphical things that we can show in the Amazon, in the Alexa application on our phones or on the web page. So imagine that you get, for example, when you ask for the weather information, in the web page and in your phone, you will see the symbol. So you will see the sun or the clouds or something like that. But anytime you think or you create a new skill, the main user input and output is always the voice. So the skill needs to work without this card, which is optional, right? And the flow is always the same. And the key part here is that the user always has to start the conversation. And this is really important because this avoids to have skills that some kind of semi-spam. Imagine that you have one of these devices and it wakes up at 4 a.m. and start playing something or talking. It will be creepy, right? So that's why they only work when the user starts the conversation. Amazon created or released a new API a few months ago to set reminders. So now when the skills have the option to set a reminder, but even with that, the user has to accept a new permission when you install the skill. The skill has to say clearly that it's going to set a timer or a reminder, and the user has to accept it. So even with that, it's pretty strict, and because they actually want to avoid some kind of spam or that device wakes up and the user doesn't know why it wakes up. And we have these two main parts when creating something for the Alexa. We have the Alexa Skills Kit, which is the SDK that we, the developers, do, or the things we create to make Alexa smarter. They provide new experience, new features to Alexa, and this is what I'm going to talk in the rest of the talk. And on the other hand, we have this Alexa voice service, which is used for adding Alexa support to hardware devices. So if you want to add support to your phone, a smartwatch, a car, speaker, something like that, you need to use that Alexa voice service. But as I said, we are going to focus on the Skills Kit. And they are, officially, there are SDKs for Java, Node, and Python. And there are also other libraries for other languages created for the community. In my case, I'm going to show you how to create skills with Java. And if we want to create a new skill, we have some kind of two parts. When we create the skills, we are going to be something like full stack developers, because we need to create the voice user interface, which is the front end. And here we design the voice interaction with our users. And also we need to develop the backend, the programming logic, the business logic, that is what is going to happen when the user says something. For the first part, for the voice user interface, what you need to do is go to that web page, developer.amazon.com, create a free account, and then you can configure everything about your skill there. We will see how it works later. And then for your programming logic, for your business logic, you have two options. The first one is to deploy the skill as a AWS Lambda function. If you know about Lambda functions, they are a small piece of code, or not that small, that just start, do something, and that they are stopped. But you also have the option to deploy that backend wherever you want, because remember, it's just a JSON API, so you can implement that JSON API. There are libraries to do that, and you can create the backend in any language you want, or whatever you want. But what I recommend for the beginners is to use AWS Lambda, because it's really simple to do that, because basically Amazon does everything for us. We don't need to worry about pretty much anything. And we can use the free tier on Amazon, on AWS. And in that free tier, we have 1 million requests per month to our Lambda functions for free. And we also have 400,000 seconds of execution, which are something like 111 hours of execution. And to make you an idea of if this is too much time or if it's not, a typical skill execution takes something like 100, 200 milliseconds if it doesn't do too much things. And if you need to call an external service from your skill, maybe it adds another 500 or 600 milliseconds, so around probably a second, something like that. So you have with those 400,000 requests seconds per month, you have a lot of free executions, so you don't need pretty much to worry about anything. Just create a skill and start using it or play with it just for free. So this is the high-level overview of the steps that we need to do to create a new skill. We create the voice user interface, the front. We create the back. Then we connect each other, so everyone, the front knows the back and the back knows the front. We test, we customize, and if we want, we also want to publish to make it available for everyone. So how do we, or how does it work, and how do we interact with an Alexa skill? So I created this is a skill for this talk, and we need to use the wake word. It's the first thing. So this device is always listening, but it only gets activated when you say the wake word. By default, it's Alexa, but you can also use Echo, Amazon, or computer. Then you need to use the starting phrase, which can be open, start, ask, give me, depending on how you say what you want to do. And then in this case, you need to say the skill invocation name. So we can say, Alexa, open Chuck Norris facts. Alexa, open Chuck Norris facts. Now it's working. It's starting the lambda for the first time.
Welcome to Chuck Norris Facts. You can ask me for a fact.
Give me a fact.
Code runs faster when Chuck Norris watches it.
Because he's Chuck Norris, of course. So this is just a silly skill that I did for the talk. And using this Chuck Norris API that you can get jokes. I will show you the code later. And you have another option if you want to interact with a skill. The last part is that utterance. Those utterance are the things that the skill does. So these only do that, give Chuck Norris facts or jokes. But imagine that you have a skill that can do 5 different things. So in the previous approach, in this one, you need to start the skill, wait for the welcome message, and then ask for something. But if you already know what you want to do, you can say everything in the same sentence. So Alexa, ask Chuck Norris facts for a fact. It doesn't work with the mic. Alexa, ask Chuck Norris facts for a fact.
Chuck Norris solved the traveling salesman problem in 01 time.
Of course.
Here's the pseudocode. Break salesman into n pieces. Kick each piece to a different city.
Okay, so you can say everything in one sentence. Let's mute it. So how it works? Remember that Alexa is the service running in the cloud, and the important part here is this NLU, this natural language understanding. This is what actually understands what we say and how we say it. And then for this to work without a skill, we need to train our skill to actually understand all the phrases, all the sentences that the user can say. And we do that defining a small JSON, or not that small, to train the skill. This is a small part, a fragment of the JSON model that I use for this skill. And you have here the samples. You need to think the different ways that the user can use to interact with your skill. So you can say, give me a fact, tell me a fact, say a Chuck Norris fact. You can, or you need to put here different options. Then we have here the slots. In the slots, you define variables. So imagine that you or the user can say, for example, their favorite color. So you will define here in the slot a variable named color. You put some samples, so red, green, blue, black, orange, a few of them. You don't need to put hundreds of them, because once you put 5, 6, 7 colors, Amazon will know that those are colors and will accept a lot of more colors. And then in the samples, you will say something, my favorite color is $color. So when the user says, my favorite color is blue, this will match, and when the front end calls the backend, it will send that color information on a variable, so you can do whatever you want. Imagine to use that, for example, for dates. So I want to do something tomorrow, in 5 days, on April 1st, whatever you want. So that's a variable. And the last and really important part is this name. This is a skill behavior. This fact intent is the name that is going to send to the backend when the user say one of those sentences. So in the backend, you need to check for this fact intent, and then you will know that the user said a sentence instead of saying Alexa stop or help or whatever, right? So I've been talking something like 45 minutes, and actually let's see some code, because I think it's better to show code to actually explain how everything works. Okay, so this code is already online, so you can play with it afterwards. I have 3 different versions of the same skill. Everything is explained in the README. So in the master branch, I'm using, can you see the font? So in the master branch, I'm using the Alexa SDK, Groovy, and JSON Slarper to connect to this internet Chuck Norris database to get jokes. On this branch, I'm using the Java approach, so I converted the code from Groovy to Java. I'm using Micronaut HTTP client for the calls. And in this last branch, I'm using Micronaut support for creating Alexa skills. So you have the 3 options we are going to see. Let's start with the first one. So this is the model I talked before. So this is the fragment I show you, and it's pretty simple. You need to define the invocation name, Chuck Norris facts, and these intents are mandatory. You can see Amazon dot something. So this is called when you say cancel or stop or help. This is used for devices with a screen, so we don't use this. And in those mandatory skills, we don't need to put any samples, because Amazon knows how it works. So when you say stop or cancel, or the French word or the Spanish word for that, it will work. And that's all. It's pretty simple. And then I want to show you, so I'm using Gradle. You can use also Maven if you want. So I have basically the dependency on the Alexa SDK and on Groovy. And I'm using this plugin. Probably there is also a Maven plugin for that, to deal with AWS. So basically, what this plugin allows me is to define the region in which I want to deploy my Lambda. And basically, if I have the credentials in that place, which I already have, I can deploy a function named Alexa Chuck Norris facts. And this is the entry point, some kind of the main of the function that is going to be executed. And some configuration, and the runtime is Java 8, this is the memory, the timeout. So you don't need that much memory. But in AWS Lambda, the memory is some kind related to the CPU. So if you want to have a faster CPU, you need to provide or to give the Lambdas more memory. So with that, it works fine. And then, so let's see this Chuck stream handler, which is the entry point. And well, this is Groovy code, but if you are Java developers, it's pretty much the same code as in Java, but without the semicolons, right? So basically, you define different handlers, and that's all. And in the handlers, you can say, for example, this one, launch request handler. All the handlers implement this interface, and you need to override these 2 methods. Can handler, this will return true if this handler will process this specific thing. So in this case, this launch request is the message, or is the entry point. When you start the skill, this launch request is executed, and this is a response. You can see here the title, Chuck Norris facts, the welcome message. This is what you heard before. Welcome to Chuck Norris fact. You can give me for a fact, some help message, and goodbye. So basically, you create a simple card. Remember, for the phone application or for the Alexa web page. The welcome message in the speech. This is what is going to be played in the device. And this reprompt, which I'm using the same message, is used if the user starts the skills and doesn't say anything for 4 or 5 seconds. This reprompt message is played. So you can put here another different message if you want. And that's all. Cancel and stop. If the intent name is stop, cancel, or no intent, this is what I'm going to say. Basically, I'm going to say goodbye, and I'm going to end the session because the user wants to quit the skill. The same for end it, for help, and this is actually this fact request handler is the skill that does everything. You can see here the name fact intent is the same name I have here, right? So that's why it matches. This JSON is for the front end, And let me close this. And here I match the same name in the backend to process the message when the user say, give me a fact. And what I do, I get some random fact which I will show you. I get the text and I play it, right? And I end the session. And in this service, so this is a URI, the API, and the output of this. I've limited the output only to get nerd jokes. You can set you can get jokes from another categories, and this is the output. So type success, the value, the ID, and you can see here what I'm doing. Using JSON Slurper from Groovy, I connect to that URL, I get the response, and basically I extract anything I want. So I want to get the text, so it's value.joke, which is what I do here, response.value.joke, and fat ID, response value.id, right? So pretty simple to do that. And that's everything you need to do. So what I'm going to do now to actually show you how to do that, I'm going to comment out this. I'm going to define here a new fact, speech text. I don't know how to type. So let's say Ivan's talk is the best, right? And what I'm going to do is I'm going to deploy this, but I don't want to override this function, so I'm going to create a new one, box days Bucharest, and I can simply say Gradle W deploy, and this is going to create a fat jar for my application, and using this plugin I show you, it's going to deploy the new fat jar into my AWS account if the Wi-Fi works. Yeah, so you can see here 404 because it doesn't exist yet, so it is creating and uploading. Yeah, it's still uploading the jar, so it will take a few seconds depending on how fast is your internet, which here is not that fast. Okay, so it's deployed, and if we go here to here, you can see I just deployed a new function 12 seconds ago. You don't need to use a plugin like that. You can just create here a function, fill everything manually, but for me it's better to just do it everything programmatically. So let's open this one, and as you can see, it's already here. The output by default is sent to Amazon CloudWatch. Java 8, this is a runtime I selected. The entry point I define on my Gradle file. Here is the memory. So everything I define here. Everything I define here is already set here, and as you can see, you need to add a trigger to trigger this function. So I'm going to select this Alexa Skills Kit, and I need to configure this. So what I'm going to show you, this is the Alexa developer portal. I have a few skills here in Spanish, and this is the one I created. So let's edit this. And basically here is where you configure this front-end part. So you need to say, for example, the invocation name, Chuck Norris facts. Here you can define with this UI all the different uteruses with the sample facts, or you can go here to the JSON editor, paste the JSON, you save it, and you build the model, and in a couple of minutes the model is built, and this NLU thing now understands everything that you put here. And here on the endpoint, I'm going to do two things. I'm going to copy this. This is my skill ID, and I'm going to put it here. Where is it? What is it? Why it's not working? Invalid input. Okay. First time it happens. And another thing I'm going to do. No, it's actually, sorry, it's the other way around. This is my skill. Let's close this. Well, this is actually, this is optional. As basically, this what this works, or how this works, is that this function can only be run or called by this skill, which I don't know why it's not working. So we can disable. So for production, don't do that. I don't know why it's not working now. It should work. And then what I'm going to do is copy this. This is some kind the ID of my Lambda function, and I'm going to replace the other one and put it here, the new one I created. So I save it, the endpoint. Let's try one more time, just in case. Enable. Okay, nah, it's fine. So probably we can try now. Alexa, open Chuck Norris facts. It's running again. It's warming up the Lambda.
Welcome to Chuck Norris Facts. You can ask me for a fact.
Give me a fact.
Ivan's talk is the best.
So it works, right? So that's how you create a skill. It's pretty simple. I still don't know why it's not working, but you get the idea, right? So what else I can show you here? I said that you can do this for free, so I'm going to show you here the billing, and you can see 0 euros. I used 216 seconds for the request for those skills I have on production for the Spanish language, and you can see that I used 450 requests out of my 3 million requests. So basically, you can deploy this for free forever unless you have a ton of users. But for playing and for doing something like this, it's great. So what else? I'm going to show you now. Let's do this. I'm going to show you the other versions so you can compare them. This one. So it's pretty much the same, but again, it's Java, so you can see the semicolons, but everything is the same. The only thing that changed is in this one, because here, in this service, I'm using Micronaut HTTP client for doing the request, so it's a little bit more verbose than Groovy, because it's Java. So this is the API, this is a URL, I get the request, I grab it into this fact, which is the pollo I'm using, type, fact, and text. And here I get the text and basically play it back. So nothing really different, nothing really interesting. And the other option is this one, which is the same. I mean, I'm using Java, but I'm using the built-in support inside Micronaut to deploy or to build Alexa skills. So the build.gradle changed a little bit, basically because I need to add Micronaut support for that and the AWS Alexa library. And then what changed basically is that I can define my handlers just with @intent handler. So I can put all of them if I want in the same file. For this small example is fine. Probably if you have more complicated stuff, you want to have it in any one, so every handler in different files. And the code is pretty much the same. The only difference here is that I'm using basically I'm using Micronaut HTTP dependency injection. So I've created this Internet Chuck Norris database client, and this client is defined here in this interface. So I use @client to get the base URI, and then when I call this method, a get to this specific URL will be executed. And the nice thing about this Micronaut HTTP client is that this interface is implemented for us by the framework at compilation time. So if you know another thing, so there are a lot of things that in which you can define an interface, and that library will implement the HTTP client for us. I think there is a OK HTTP, another one for Android, one from Netflix or from Spring, I think it's called Fein or something like that. All those libraries implement this at runtime with runtime proxies and all that kind of stuff. Micronaut does the same, but at compilation time, so you don't have all that overhead. And once you have the implementation, just inject the dependency, constructor injection, and basically you can use it the same as before. I get the text or an error, and I play it back, right? So nothing different. This code is already online. I will put the URL later at the end of the talk. So you can play with the different versions. You can compare. You can do pretty much anything. The only thing you need to do is create your account in the Alexa portal and in AWS Lambda if you want to deploy. And if you want to use the Gradle plugin, you need to put here in your home directory .aws. Here you can set the credentials that I'm not going to show you. Right, they are private. And I think that's pretty much all. So as a summary, it's really simple and easy to develop skills. I show you how to do that with Groovy and Java, basically using the same SDK. You can use Kotlin if you want, or probably Scala if it works on AWS, on Lambda. The certification process is a real pain. So when I created the first skill in Spanish, it took me more than 3 weeks to get it approved. Because you submit the skill and they start testing a lot of different things. Actually, not that a lot, because once the first thing fails, they send you an email saying this fails. And you say, okay, you fix it, submit it again, and you need to wait, because the certification process takes at least 5 business days, which means that if you do that on a Monday morning, until next week, you are not going to have an answer. And probably next Monday, next Tuesday, you will have an answer, and if it's rejected, you do the same and start over and over again. So it took me more than 3 weeks. But now, I think they have improved a lot, or at least a little bit, the certification process, so it's not that pain, but it can take some time. What else? A voice interface doesn't change our lives, right? So it's not something like, at least for me, it's not like you can say, how I was able to live without one of those devices for my whole life, right? At least for me, it's not like that. But it helps to make things easier. I can just use my voice without taking care of anything else. I imagine that, for example, you are in the kitchen following a recipe. So with your hands dirty, you don't want to touch your phone with your hands dirty. You can use your voice and to talk with your device to say, there are a lot of skills to follow cooking recipes. So you can say, next step, repeat that, convert how many ounces or milliliters are 2 ounces. I don't know, but you can ask with your voice, right? For me, this is a new market, so it needs time to grow up, to evolve. They need to think or to have a way to monetize this. I think it was this January or December, Amazon launched a new API to allow to have some kind of in-skill purchase things. So the same way that you have your a game on your phone and you have you can buy things for the game inside the game, right? So you can now do that from the skill. I haven't tried, so I don't know if it works or how it works. But that's a new way. So because at the end, someone needs to make money, right? These devices, so in the US, they've been selling these for probably 5 years now. And it took them 5 years until this January or so to think or to have the critical users to think about monetizing these things. And also, one nice thing is that these devices are really cheap. So you don't need to spend a lot of money. This one, or actually the new one, this is the version 2, the third one, it's only, I think, 50 euros or something like that. When they launched it in Spain for the Black Friday, this one was only 30 euros, which is not that much money. So if at the end you buy one of those and it's not, so you don't use it or you are not comfortable to having one of these devices, it's not a lot of money that you wasted. You can still use this as a Bluetooth speaker, so you can send your music from your phone, from your computer, because it's a Bluetooth speaker. And as I said, they are cheap. It's not like, for example, the Apple one, which I don't know how it's named, but I think it costs something like 300 euros, which is a lot of money. If you are not going to use it and it's going to end in a drawer somewhere, 300 euros is a lot of money, but 30, 40 euros is not that much, right? And basically that's all. That's my contact information. The repo I show you is already there on my GitHub account. I will tweet with the slides and the code later. And if you have something like 30 seconds, you can go to that URL, bit.ly alexa-bucharest, or that QR code. It's an anonymous Google form to send me some feedback about the talk. It will only take you something like 40 seconds. There are only 4 questions. And it's anonymous, so you can say whatever you want. If you like the talk, please let me know. If you didn't like the talk, if you think that it was a waste of your time, just let me know. I won't be offended. Just send me some feedback. And now I think probably we have some time for questions. Thank you. Yep.
How did you make your skills available to this specific device?
Yeah, so the question is how do...
If I have an Alexa at home, can I access the skill that you just deployed now?
Yeah, so how do I make available my skill for this specific device? So this device is linked to my account. So any skill I create, so if I go back, what is it, here, you can see here, these are my skills, right? These are duplicated because there is one version that it's live, this is running on production, and this is the development version of the same skill. So all those skills that are live are publicly available for everyone, but all the skills in development are just available for your own devices. But if I want to share this skill with you, I can invite you. There is somewhere probably here, I think it's here in distribution, or maybe this is for the yeah, basically I can invite you, so I can send you through the page. I can send you an invite, and you can use it on your own device, some kind of beta access. So you don't need to make it public. And you can also use that. Imagine that you want to use this for, I don't know, inside your company to call an endpoint. Is there any server down? So you don't need to make it public for everyone. You can put it on development mode, which is the default one, and use it, share with the device or with the account that you use for your device in your company. Yes?
Does Amazon provide a way to do an end-to-end test without actually owning the device?
Yes, that's a good question, and I can really show you. Here you have this test tab. So basically you can say here, you don't need to use the, let's mute this. You don't need to use the Alexa. You can say always start Chuck Norris facts.
Welcome to Chuck Norris Facts. You can ask me for a fact. Ivan's talk is the best.
And you can see here, this is the input, this is the output. So this is actually the JSON that my skill is sending back. And you can see here down how does it look like on a device with a screen. You can even change here the devices. And another thing I forgot is this one. This is the Alexa portal, and here you can see the same, right? Let me do this. You can see all your execution. So this is what I did. Another Chuck Norris facts. How much is 100 factorial? The weather. You can see here all the symbols, the sun, the clouds, everything. So you can see here. Tell me a joke. Everything you can see here, and you have the same some kind of interface for the application on your phone. So you actually don't need a device to do that. You can test everything here in the same tab, and you can click here and talk to your computer microphone, and it will work the same way if you give it permission. Yes. Probably, so to my device or to my skill? Only one. I mean, only one. It doesn't, so there is no security. So if you say, Alexa, what time is it? It will work for you. So only one, because once you, so when you say, Alexa, now it's listening. So what time is it?
It's 11:19 a.m.
Right, and now the circle is off. But anyone can use it. So it's, yes, it's connected to my, it's connected to my Google Calendar account. So yeah, I think there is something, so Google has that to switch between accounts. And I'm not really sure if Amazon has something like that.